To understand dynamic programming, let's take a look at this problem. Let's say that we are given an n stairs where you can climb either one or two stairs at the time. So how many distinct ways you can climb to the top? And in our case, let's take a simple example where we have only 4 stairs. And if we solve this problem, the function for solving this problem looks like following. So what we are doing here, for the 4th step, we can come either from the 3rd stair or from the 2nd stair. So the climb stairs 4 is equals to climb stairs 3 plus 2. For the 3rd, the same, we can come either from the 2nd or 1, and from the 2nd we can come either from the 1st stair, or we can start from the very beginning and make it 2 steps, right? And for the stair 1, we have only one way to climb those stairs. So what we are doing here? What we are doing here is that we are solving the same problem over and over again, right? So for example, climb stairs, we have already solved that problem at the stairs 3, but at the stair 4, we are again trying to solve the same problem. The same is here. We have solved the problem for the climb stairs 1, and we are trying to solve the same problem at the 2nd stair and the 3rd stair. We are trying to solve the same problem. So as a result, the time complexity of this solution is exponential to the power of n. Why it's a to the power of n? Because for each stair, what we do, we have 2 options, right? And those 2 options have their 2 options on their own, and those 2 options have the 2 options on their own. So our time complexity is exponential to the power of n. Can we reduce that? Can we reduce the time complexity? Yes, we can do that. And the way we do that in the dynamic programming is that we are creating an array, and once we solve the problem, we are storing the solution to the array, so we can later reuse that solution, because we have already solved that subproblem, right? We don't have to solve that again. So we are solving that the intermediary solutions to fetch them later when we try to solve the same problem again. So here, for example, first we are solving a problem with the climb stairs 1, and we have only one solution here. So we are saving that to our array. And for the climb stairs 2, we are again solving the problem, and we are storing that to our array. For the 3rd one, when we're trying to solve the problem, it's basically climb stairs 2 and the climb stairs 1, right? So what we have already solved the problem, we don't have to solve them again. So what we do is, instead of recursively calling those, what we do is we are getting those values from the array, right? So we are not solving those problems. So we are getting those values from the array. And the same way for the climb stairs 4, instead of recursively solving those problems, we have already solved them, so we are fetching those values from the array. So 2 plus 3 gives us 5. We are storing that into our array, and we are returning the result. So if we introduce this optimization, what we do is we are reducing our time complexity from the exponential to linear. So now our time complexity is of n, because every problem we are solving only once. So this technique that we have just introduced, we are calling it memoization, and usually we call the array as a memo. So what we do is here, right, as you can see, we are introducing an array, and before solving the problem, what we do, we are checking that if the n is in the memo, so for example, in our case, right, let's say 2 and 3, let's say that we are at the stair 4 and we are trying to solve a problem for 2 and 3. For 2 and 3, they are already in our array memo, so we are checking that if they are in memo, then we are not solving those. We are not recursively calling for the stair 2 and the 3 in case of 4, right? We are fetching that from the array. This technique is called memoization. The simple to understand it is basically caching, right? So we are caching our intermediate results to the array, and later when we need those, instead of solving the same problem over and over again, we are getting those values from the cache or from the memo, whatever you want to call it. And if we do that, if we introduce this simple optimization, so what we do is we are reducing our time complexity, in this case from the exponential to the linear. So this solution is when we are using a memoization with the recursive call is called top-down approach. So we are starting from the top. So what we do is we break down the problem to the smaller and smaller subproblem until we solve the smallest one. Then we are building up to our solution. So for example, in our case, for case 4, right? So what we do is we are breaking down that to the smallest subproblem to 1. We are solving 1. We are solving then 2. We are storing that to our array, and then we are building up to our solution. And at each consecutive step, what we do is instead of solving that problem, instead of recursively calling and solving that problem again, we are checking first in our memo. If the solution is in the memo, then we are taking that solution from the memo instead of solving that problem again. So that's the first approach for the dynamic programming. Top-down approach. Another approach is called the bottom-up. So in the bottom-up, so what we do is we are from the very beginning, we are creating an array. Let's call it DP, dynamic programming. What we do here is we are solving the smallest subproblem, and then we are building up to our solution. It's a reverse what we just did. In this case, we are just starting from the very beginning. We are solving the smaller subproblem, and we see that the subproblems that we have already solved, can they lead to our solution? So for example, in this case, how many ways go to the first step? The way to go to the first step is only one. So the way to go to the second step is that either from the beginning, it's a one step, or we can go from the first step, right? Then with the ways to go to the second stair is 2. So the same way for the third one, we can come either from the first stair or from the second stair. Then either from the first stair or the second stair. So the value for the third stair, how many ways we can go to the third stair, is 3. 1 plus 2. And if we put that into formula will look like following. dpn is equals to dpn minus 2 plus dpn minus 1. So for each consecutive step is basically that the sum of the 2 previous steps, right? For example, for 3, it's 1 plus 2. For 4, it's a 2 plus 3. For 5, it's a 3 plus 4, and so on. So then if we summarize the bottom-up approach, so what is the bottom-up approach? Bottom-up approach is that we are starting from the bottom, we solve 1 entry or 2 entries and so on, and then we are gradually building up to our solution. So we are solving the smallest subproblem, and then we are building up to our solution. And if we put that into formula will look like following. So instead of creating a recursive call, so what we do is we are creating an array dp, and we are solving problem dpi in our case, right? It equals to dpi minus 1 plus dpi minus 2, right? So for example, for 4 it equals to 3 plus 2, for 5 it equals to 4 plus 3, and so on, and at the end we are returning whatever the result that we get. So for example, in the case of 4, we are returning the result whatever we have saved for the 4, right? For the 4th stair. So whatever result we have saved, we are returning that. And in this case, again, the time complexity of this solution is also of n. So in both of these cases, in the bottom-up approach or top-down approach, the time complexity is of n. So to summarize, how many ways we have to solve a problem using dynamic programming, right? We have 2 ways. First one is that the top-down approach using a memoization, or simply let's call it caching, and another one is the bottom-up approach where we are solving a smaller subproblem and we are building up to our solution. So to summarize that, we also can say that every problem that is solved using the top-down approach can be also solved using the bottom-up approach. I have another video in my channel, so you can check it. So as an example, one problem is solved using the top-down approach and the bottom-up approach. And when you are just starting with the dynamic programming, I would advise you to do the same, to solve every problem with the top-down approach and the bottom-up approach. So then in that way you better understand what is the use of the dynamic programming. So Now let's go to another question. So now we understand the dynamic programming, but the question that you usually asked is, how do you identify when dynamic programming is the best approach to solve problem? In other words, how do you know that in this specific case I need to use the dynamic programming? So how to use the dynamic programming and in which cases to use dynamic programming, right? There are some tips. The first one is that, for example, start with the smaller subproblem. So let's say that you are given a subproblem, you are given a problem, right? In that case, so what we do is first approach as a first tip. What we can do is we can start with the very small subproblem. When the size of input is equals to 1 or 2, solve it, increase the input to 3, 4, and try to find the pattern. So for example, in our case, right? So what we do is for the climbing stairs, we can say, okay, for the first one, for the first stair, we have only one way. For the second, we have two ways, and for the third and for the third, we can come either from the first or second stair. For the fourth, we can come either from the third or second stair, or for the five, we can come from the fourth or third stair. Then the formula here could be that the n formula here is that the n is equals to n minus 1 plus n minus 2, right? So whatever step you are, whatever step you are, the formula is here that you can come to that stair, to let's say that the stair of, let's say 75, right? So you can go to that stair from either from 73 and the 74th. So we need to solve a problem until the 75, right? So we need to solve every problem starting from the very beginning, and at the end what we are doing is we are basically taking the sum of 73 and the 74, which gives us 75. So to summarize that, we are solving a smaller subproblem, and then we try to find the pattern from that. Then we're trying to put that into a formula, right? Then we try to put that into function. Okay, in this case, for example, it would be n is equals to n minus 1 plus n minus 2. So another way is that we can, for every problem, right? Let's say that we cannot come up with that solution. So what we can do is we can, every problem of this nature, so what we can do is we can solve the problem with the recursion or backtracking, and then we can optimize using a dynamic programming. Let's say that for the top-down solution, right? So we are using that with the recursion, but we see that, okay, we are solving the same problem again and again. So at that step, we can introduce caching or memoization and optimize our problem. And the last one is that if your problem is requires optimization, so when we need to find the maximum or minimum or path or sum, etc., in those cases we are using a dynamic programming.